Good morning, class. Remember when I said that I promise I will never miss another day in the rest of the semester? I lied. I will be back tomorrow. Today I am just at a workshop learning on how to write some cross-curricular projects. Nothing you guys need to worry about. So, today, you guys know the drill. You are going to do some notes via the video. You are going to do some example problems via the video. And when you finish early, because almost certainly you will, you're going to work on benchmark 1. If there are any questions or concerns, write them down or email them to me or something, and I will promptly ignore them. So, pretty easy day. We'll go ahead and get started. You are in your interactive notebooks, which means you do in fact need to have it out. Each and every one of you need to have it out. And a writing utensil. Yes, I'm talking to you. We are on page 77 in our notes. Alright, so we're going to start by talking about how energy is kind of like money. This is called an analogy. When you have something and you're saying it's kind of like this other thing, and they're not actually like it all, but it does help you think about it the correct way. So here we go. Work is when you add energy to a system. Kinetic energy, that's when you have energy that's causing you to move. And potential energy is when you got energy that is stored and not being used. Our analogy is that work is like when someone gives you money. Kinetic energy is like having money in your pocket. You've got that nice little bounce in your step, you walk around with your head held high, all that. And potential energy is when you got money in the bank. It's your money, you have it, you're just not doing anything with it right now. Alright, some examples to go along with this. Oh, and in case you haven't figured this out, this being a video, you can pause if I'm going too fast. So that's not a complaint I should hear from anyone. Scenario number 1. You got a boss. Your boss gives you $100. And you got no money in the bank. So, here's the boss. He sends you the $100, but he doesn't give it to you. He puts it in the bank. Oh no. Why didn't the button work? Oh well. Yay. There it is. So now you have $100 in the bank. Let's do that again with the, animation actually working, huh? Alright, let's try this again. I'm the boss! I got money for you! Yay! Except it's not going to you, it's going into the bank. Still yay? Alright, now an explanation of what that would actually be in physics. You got a box, it starts on the ground. It has no potential energy. Then this guy comes along and says, I'm going to do 100 joules of work to you, box. The box says, yay! The box now has 100 joules of potential energy. Giving you money, giving you energy. Very much the same thing. Alright, one step more complicated. Scenario 2. Your boss gives you $500. Yay! Except he doesn't give it to you. He puts it in the bank for you. So, even though you started with $100 from before, since your boss just gave you $500 more, you now have $600. I know, this stuff is crazy. Absolutely super complicated. It's ridiculous. In physics, what that is, well, you got the guy before, he already has the box. It's already with 100 joules of potential energy. Well, now he says, well, now I'm going to do 500 joules more work on it with my abnormally long, stretchy arm. So if you start with 100 joules of potential energy, and then you get 500 joules more via work, you now have 600 total joules of potential energy. Wow, that's absolutely crazy. What are you talking about, Mr. Sasso? This is not worth taking notes on. Except, yes, it is. Which means, yes, in fact, You're supposed to be writing this stuff down, drawing little pictures, all of that. If nothing else, I at least need the scenarios and explanations written. So the scenarios, boss gives you $500, you already got 100. You're holding a box, it already has 100 joules of potential energy because it's above the ground. You then lift it with 500 more joules of energy, giving it a total of 600 joules of energy. Alright, so now we have an example. You got a 25 kilogram box. It starts on a shelf 5 meters above the ground. It is then lifted with 500 joules of work. What is the final height of the box? Well, how would I do this? Well, I'm going to start by writing stuff down. 25 kilograms, my initial height is 5 meters. I then lift it with 500 joules of work. It's the final height. The key here is what we're talking about over here. Except now we're doing it backwards. Work equals the change in potential energy. I don't care, go away. Where potential energy is mgh. So what this means, work equals your final potential energy minus your initial potential energy. I can find my initial potential energy. Look at that. Initial potential energy. That's going to be m times g times h initial. I get a number. I don't actually care what it is right now. You can do that. I'm not going to do it. I know what the work is. It's 500 joules. So I can take this, and I can plug it in there. Take this, and I can plug it in there. And I can solve for PE final. Which I then plug into this equation. It goes m g h. And now I can solve for h final, that thing I actually care about. Alright, now I'm ready to actually, do the thingy. So I need my calculator. Let's see, that's a good spot for it. 25 times 9.8 times 5 equals, okay, so that's 1225 joules of energy, so that puts that in there, where that's 500. So I end up with 500 plus 1225 equals a final potential energy of 1725. Which gives me a final height of, okay, well, whatever 1725 divided by 25 equals, divided by 9.8 equals 7.04 meters. Yay! Questions? Concerns? I can't hear you, so it doesn't matter. Moving on! So, we just did two scenarios that involve potential energy. I now have two scenarios for you that involve kinetic energy. Now, at this point, I got bored. I stopped making animations, so I'm just going to draw it as I talk. So, here's you. Yay! You got no money. So, maybe not so yay. But then some random stranger comes up and says, hey, sad person, you should be happy. I'm wearing a top hat. Have this check for $100. Now you're happy, because you have $100. Yay. The explanation of this. So you have a box that starts at rest, which of course means that your kinetic energy starts at 0 joules. If you then get pushed with 100 joules of work, since work equals the change of kinetic energy, remember? You start with 0 joules of kinetic energy, you get 100 joules of work, which is kinetic energy. This ends up resulting in you going nice and fast, kinetic energy of 100 joules. Ooh. Hopefully you can sort of see what the pattern is here and where I'm going to go with this. Scenario 4. So you're already pretty happy, right? Because you already got this check for $100. Then this other person comes up and says, hey, happy dude, you should really be super happy, because I'm going to give you this check for $500. So you already got $100. He gives you $500 more. So now you're like super happy, because in addition to your $100, you also have now $500 for a total of $600. Craziness. So I got a box. This would be the real life physics example. You got a box. It has a velocity of 5 meters per second and a mass of 5 kilograms. Someone then comes up and kicks it. Doing 500 joules of work to it. Okay. What's the final speed of the block? It's still 5 kilograms, but now it has some V final, of which I don't know. Alright, well, I need to know what the kinetic energy is. Then I'm going to say, well, work is equal to the change in kinetic energy, which will tell me what the final kinetic energy is. And then I'll be able to solve for V final. Alright, kinetic energy, that's 1/2 mv squared. So this kinetic energy, oh hey look, 1/2 times 5 times 5 squared. Alright, I'm going to take that kinetic energy, and I'm going to take this work, and then it'll let me find my final kinetic energy, because, if you remember, work is equal to kinetic energy final minus kinetic energy initial. This is my initial. This is my final. I'm going to take that, I'm going to plug it in right there. I'm going to take this, I'm going to plug it in right here. It's going to be then this, which will be that. I'll get a number. And I also remember, though, that kinetic energy is 1/2 mv squared, which will let me solve for my final speed. Calculator time. Alright, so, what's my initial kinetic energy? Well, that's 1/2 times mass times speed squared. I already know what 5 squared is. It's 25. So, my initial kinetic energy is 62.5 joules. I then add 500 joules to that. That gives me 562.5 joules. Alright. So I got 562.5 joules. 62.5 equals 1/2 times 5 times v squared. Solve for v. That's going to be that number. I'm going to then multiply both sides by 2 to get rid of the 1/2. We'll divide both sides by 5 to get rid of that. That leaves me with number equals b squared, so I want to take the square root of that, which gives me 15 meters per second. Yay! Yes, that was all very, very fast, but hopefully really, really obvious. What I now want you to do is I have these 6 problems. These are harder. I want you to use your notes from the last 2 days and work together in your groups to try to find these answers. The first thing we will do tomorrow is we will talk about these problems and we'll make sure we all have the correct answers. Then we will do lab. When I say go, you're going to do these 6 problems together in your groups. When you are done with these 6 problems, you will then do benchmark 1. Questions? Concerns? No? Then go. Where's the stop button? Stop button disappeared. There's the stop button.